AI on AMD GPUs. So the focus is I'm going to spend basically this is a reply to 2 comments I got, even though I've made since those comments from the first comment I actually created a bunch of videos which explain the answers. I guess the viewer did not watch those videos, so I'm just gonna compress everything into this video. And the second comment, I actually got it today in the morning, and that one was somebody was requesting that I show a beginner level way to install local AI for AMD GPUs. So the first one, which I almost forgot, basically the person was saying that when they use ComfyUI, when they put pipe, -r install requirements, it installs Nvidia stuff. So I'll show you how to prevent that in today's tutorial. I've talked about it, but some people I guess did not they didn't watch the other video. So I'll explain all that. So there's about 4 or 5 videos I made, including articles. I have the links all in the description. So with that out of the way, let's get started. The first thing I'd like to do is implore you to subscribe, like, follow, and leave comments, because the more people who subscribe, the more this content gets pushed out to more viewers. Those viewers will then join this growing community, post tips and tricks, or they will post requests which I'll review, and then I'll share with everyone. In fact, I think one of the first times I actually did anything related to AI, one of my viewers, it was actually a night stream. It was like a 3-hour night stream, and that viewer walked me through all this stuff. It was way above my comfort level, because I didn't come close to doing the research. I just wanted to get something up and quickly. But so I'm saying is, obviously I understand those things as well. So now I'm gonna impact my knowledge onto all of you. Okay, now onto the intro. You see the intro says no Nvidia, no problem. So even if you have an Nvidia GPU, this will also help you, because some of you might have a very old Nvidia GPU is no longer supported. So you might be using something like Vulkan. So you need to you still need to I guess basically not have a Nvidia stuff installed and get, say, Vulkan working, or maybe just the CPU. So I'm going to show you how to do all that in today's tutorial. All right, now this is the article that was the focus of the day stream today. So I'm just going to quickly summarize this in case some of you because some of this stuff is relevant. So basically I talked about local AI architecture, GGUF, and quantization. Basically all you need to know is, if you're limited in the GPU or RAM, you can still run very large language models, or what do you call them, not AI, image or video models. So basically what you do is, most of the models you find, for example, in Hugging Face, they are put there by researchers. It doesn't matter what company it is, they're researchers. So they're very, very, very huge. So what happens is, especially when they're open source, is that the community will then come down to quantization in GGF version. So what that means is, like, as I shared earlier, for example, a very popular one is Wan 2.2, the video model. It's very huge. Vast majority of people, I would say probably 95% of the people on the planet are not able to run those Wan 2.5, especially the 14B or even the 2.1 14B models on their GPUs. Especially most people now usually have laptops. So what happens? The community takes it and they quantize it, make the Q8, Q6, Q5, 4, 3, 2, and so that will be able to run it. Obviously, the position degrades, but you can still get very decent results, even some very good results. And I'll show you some of the results I have when we test this. So that's basically what this article is about. And as I was saying before, is you see most of the models you get, they will be, especially from the researchers, they will most likely be 16-bit, meaning they have precision. So the community will then take that and create, for example, 8-bit versions. That's where you see Q8. They'll make, for example, Q6. Those are all quantized models. They'll create that. So as you can tell, if you have something that's 16-bit and you try to convert it to 8-bit, clearly you're going to, you see the size is half, right? Roughly half size. For example, this is a 7B model. So what happens is it's going to be much faster. That's because it's losing half of the precision. And there's some models which are 32-bit, so meaning that they're full precision, and some even 64-bit, meaning double the precision. So those ones, most people will not be able to run them on their local, locally on their computers, laptop or otherwise. So that's why having a lot of RAM, not VRAM, RAM is also important as well. So that's how people, but RAM is much slower than VRAM. So the example I used today was llama.cpp. That's the C++, C++ engine for these local models, especially for chat models, and that works fantastic. I run it. I didn't actually run it, but I'll show you how to install it. That's basically what this tutorial is about. And there's also a version for generating images and videos. It's called stable-diffusion.cpp. So that one works extremely well. You don't have to get all these huge Python libraries. It just runs in C++ as well. You can also compile it if they don't have a binary version. And I'll show you that as well. So this was the earlier tutorial. I said this is the afternoon tutorial, and this is the night stream. So this is the one here, and we're live. So we're live on YouTube, Rumble, BitChute, Odyssey, Kick, and Twitch all at the same time. And I remembered to put the social stream ninja, so your chat will display somewhere around here. Okay, and I'm gonna end it right here. Okay, now in order not to waste any time, I'm gonna make some assumptions is that you guys understand. I said I don't want to repeat everything I did in this tutorial because that was just repeating. So essentially, you can go to Hugging Face and grab the GGF models or somewhere else. It could be GitHub, Civic AI. Yeah, you can get them all from there. Even llama.com. There's also, I think, llama.org. I don't know what the difference is there, but the point I'm trying to say is that you can run the models from those places. Now, this is about installing. So, for example, let's go to llama.cpp. And I also have other articles here. You can simply search for Jumbo. You see, this one was the one. This is actually my very most popular AI reader one. It's when I reviewed the Wan 2.2 text to video 14B model, and you see this is a very old one. It's from 2025 in October. Since then, I've been able to improve it and actually get it working. I use a quantized model. So this is here. Now the reason I keep on referring to this one, there's a reason why this is also popular. It's not because of the Wan 2.2 only. It's because I explained what my GPU is. The GPU drivers I was using at the time. Obviously, I upgraded to Fedora 43, so I have ROCm 6.4, and how much RAM you should really have to run this model. But you can get away with 32 gigs absolute minimum, and I'll show you how, because I only have 32 gigs. I'll show you how you can do that. SSD is recommended. If you don't, it's going to be very, very slow. PyTorch, this is using ComfyUI, of course. And then I explained, so this is the problem right here. A lot of people get into a problem, so I'll explain how you can fix this. If you have an AMD GPU, when you run this, it will try to install Nvidia drivers, right? So for the GPU, even though you don't have a Nvidia, for example, I have an all AMD system, a Ryzen 5 5600 GT CPU, and an AMD Instinct MI60. There is nothing to do with Nvidia, but for some reason it tries to install because some of the the nodes are hard-coded for Nvidia. Okay, so as you can see here, I explained all of this. So now, if you have less RAM, some of the suggestions. This was back then, and the temperatures, as you can see here as well. So I said I resolve all this. What I did was I removed the swap file. Sorry, I increased the swap file. I removed the Z image turbo. So you see this ZRAM here. I actually removed. I've since removed this and just increased the swap file instead. And yeah, just to see. Yeah, this is what I was trying to say. See, FP32, that's full precision. That one uses the most, obviously, most RAM, VRAM as well. And then it's half precision, that's floating point 16. And I said floating point 8. My GPU doesn't have floating point 8, but a lot of new GPUs, especially consumer ones, they do have floating point 8. So you guys are pretty lucky if you do have that. So I use quants. You see GGUF, Q, especially Q4KM, M stands for medium. And you can see the, so you see what happens, right? The memory goes down, and you can see the quality or the fidelity. So you can see this one is highest because it's twice the precision. No, sorry, this is full precision. I apologize. I was thinking of FP64. FP64 is double the precision. So this is the highest one. I've actually seen one model that was FP64. I've seen some which are FP32. So most of them you're going to find are going to be FP16. That one has a minimal quality loss compared to FP32. When you have a floating point 8, that one has a good negligible loss for the most inference tasks. That same is, you can say the same thing for the Q8 as well. That's an integer one. And as you can see here, there's a little balance here as well. So I wouldn't recommend going below Q4. But some models, like I said, like the Z image turbo, they're pretty good. You can go actually Q3 as well, and I will test that. I'm not going to download it, but I've tested that before, and it's pretty good quality. But I'll show you that. And then here's the surfaces. S obviously stands for small, M for medium, and large. So I go for large whenever I can, or if I can't, I'll go for the medium one. So basically, medium is and offers a best blend between speed and quality. So that's why I like to go with that one. And as I already explained what all this means and which one you should go for. So yeah, so this was based on the Wan 2.2 14B model. So you can see there's low noise, high noise, and which one to get. Yeah, so I've actually improved in this, and so no wonder this tutorial was very, very popular. Do I minimize this? Okay, there we go. Yeah, so people were able to follow this one. I even explained. Okay, so speaking of installation, obviously if you have this, you can use the ComfyUI manager. I removed it. I'll explain why I've removed the ComfyUI manager. It's because it has two annoying things. What it does is, you know how every time you do something you have to restart ComfyUI? Then the ComfyUI manager, it will then look for updates, even though it's the second or third time in like less than 5 minutes that you're restarting ComfyUI. So I find that really annoying. And the other thing is, this is not a problem with ComfyUI manager, but there's one node that was obsessed with installing Nvidia stuff. So that really ticked me off because my storage space is limited. So that's why I prefer doing manual, because I can stop it. That's part of the tutorial today. I'll show you how to do all that stuff. So we talked about this. Yeah. So as I said, this is a pretty explained the case sampler, free memory. This is another way to speed things up. You can throw this memory cleanup. I'll show you that with my own personal ComfyUI setup. And of course, I would recommend using, making sure you clear the cache as well. I'll show you how to do that as well. The key part is you need to know your GPU, what your limitations of your GPU is, and what your GPU is capable of. So don't just simply follow what everybody else is doing. And as you can see here, this is this is the mistake I made back then, because I didn't understand this FP8 stuff. My GPU doesn't support FP8, so this was terrible. So my GPU does support integer 8. So what I should have done, I should have gone the Q8 ones as well and use a unit or the GGUF version instead of using this one. But if your GPU can support it, yeah, absolutely, go ahead and support it. So I'm saying that my mistake before was using FP8. What I should have done is use this one, the Q5 or Q6 or even the Q8. Q8 is probably going to be a little bit too big. But yeah, Q5 is perfect fine. That's what I'm using actually right now. I'm using, I believe, Q4KM. And so that was this tutorial here. So I'm going to close that. And then this one I did very recently. This is an update on that tutorial, and I got it working, and it produces things very, very, very fast. You can see you can also do things like low VRAM, then we'll use your RAM. But if you have low RAM as well, that's not a good idea, because you don't want to be offloading to the CPU. So that's what I'm saying. You see the FP16 one, it needs at least 60 gigs of memory combined, meaning that your GPU and your system RAM. I don't have this to spare, so I'll explain to you how I got around that. And I mean, so this is to answer one of my viewers' questions, is that how did you install? So what I did was, my GPU, the AMD Instinct MI60, it's last officially supported by AMD for ROCm 6.3. So if you want something smooth without any problems, you can use Fedora 42. It's still supported, and you put it in something called a distro box. So that's how I installed it. So I have a video here. I installed it. It worked really, really well. However, my daily driver is a Fedora 43, but it comes with 6.4. Now don't worry about it, because all AMD did was they just removed the tensor files. So if you put back the tensor files, it works perfect. So I'm able to run, and I'll prove it to you. I'm able to run ComfyUI without any issues as well. So here's my system. You see it's a Ryzen 5 5300 GT. The G stands for the integrated graphics. Yeah, integrated graphics, because I need that to power the monitors. And the dedicated GPU, this one here, MI60, that one is 32 gigs of VRAM. Now here's the problem. This has changed a little bit. So if you see here, the dedicated GPU has 32 gigs of VRAM, but my system only comes with 32 gigs of DDR4, but I don't really get all that 32 gigs. Here's why. The integrated graphics reserves 4 gigs of that, so we're down to 28. And before, when I had ZRAM takes 4 gigs of that, and then it compresses it, so it gives you like 8 gigs, so you don't have to go to the swap space. So I've removed the ZRAM. Now I have about 28 gigs, but it's, as I said, that's not true, because, for example, like right now I'm running OBS. I have a whole bunch of web browsers open. I have the Social Stream Ninja open. I'm running multi-stream using FFmpeg, so it's going to use a little bit of RAM as well. Plus, when you run AI, you need a little wiggle room there as well. So unfortunately, I won't be able to increase the this RAM or the storage space, because the prices went way ridiculous, and I'm not going to get ripped off. So anyway, so you can follow this tutorial here. I said I have videos for this as well. Again, I see a Q8, I got smart integer 8. This is what my GPU supports. So you see the double precision is 7.4 teraflops, full precision is 14.7 teraflops. Is it a double? And then if we go to FP16, which is half, it's 29, basically double. And then if so normally this is what people recommend. Oh, use BF16. My GPU doesn't support BF16, so I can't use that one because it's just going to convert it to FP32 or FP16. But it still be better than, for example, FP8. If I try to do FP8 or something new now, FP4, all you have to do is to convert it to FP32 or FP16. So it's going to be a little bit of an overhead there. So I'm much better off using something that my GPU actually supports. That's usually a Q8 integer 8, or like this one's a Q4 whatever, because it'll be so fast anyways, it won't matter. So what I'm saying is my particular GPU, this is the fastest integer. I've actually found models, one model which was completely integer 8, and that one flew. I was really, really surprised. So yeah, if I can, this is my preference. If I can't, I'll see if I can fit this. Usually not, especially for video. So usually I go to Q4, as I said. Another reason, now in theory I should be able to run this if I had enough RAM. I wouldn't even bother going to these guys. I'll probably stick to this half precision. But I said I don't, so that's why I use the quantized models. The quality for me is perfectly fine for now, because I just focus on claymation images. So I was able to get this working in Fedora 43 and 42. So 42, I installed it using the distro box. You can see here I have all the commands here. It's pretty simple. Obviously you need distro box and podman, and then you just you grab the Fedora 42. You see Fedora, what version? 42. You enter. Then all you do is just clone. You create a Python. I believe it came with Python 3.13, and then you just clone the latest version of ComfyUI. Then you create the virtual environment. Then you run pip install requirements.txt. Now, some of you might notice something interesting here. I left something out here. Now, is that my fault? Well, I made an assumption, so I'll tell you what assumption I made. My assumption was that you guys would install a ROCm, so I didn't tell you how to install ROCm. So there's two ways to install ROCm. If you're using Fedora 42, 43 and above, install it from the repos. The one from AMD is just going to be a pain because it's not officially supported, and they will have like old libraries. Just install from Fedora. It's really easy for you, especially if your GPU is supported. If it's not supported, you have to have a Node one. I get it. What I'm saying is that if your GPU is supported, not necessarily by AMD but by Fedora, and I'll give you a link where you can check to see if your GPU is supported. And then here, you see what I did? Here's the trick. On my Fedora 43 system, I did not install PyTorch, PyVision, or Torch Audio using using pip. You see, I installed it from the packages because Fedora is probably the best distro for AI, at least at the time of this recording. So you see, I can install those packages, and that's what I did. I installed them. So the benefit of installing it from the repository is also that they're obviously maintained, but they take up less space. So when I do this, I can install everything in about 10 gigs. It takes up about 10 gig space. But if I use pip is going to use 25 gigs. You see, so that's 1.5 or 2.5 times the space. And I said that my space is kind of limited because I didn't pick up NVMe drive. I was hoping for the prices to drop. The prices went up. And then after that, you can then run this Python space main.py, and then you just open up your browser. So that's basic. Hope that answers your question. I didn't get the name because I don't know if they want me to type the name. So that will take care of that. So basically, everything is installed. You still need to run this pip install requirements text because there's some things which are not in Fedora, at least in Fedora 43, and obviously Fedora 42. But once you install ROCm and that, you'll be perfectly fine. All right, as you can see, I got it working, no issue at all. Both Fedora 42 and Fedora 43. In fact, I even did a night stream where I compared FP16 versus Q8. And this is the tutorial where we found out that I believe Q8 is the fastest, meaning that what the what do you call it? What AMD, or at least the documentation, is actually true. Okay, and then I also did this one. What was this one here? What was this one here for? I don't remember. Did I come here? Oh yeah, just show you what my system is. So this is my system right now. I'm running this is my CPU, the RAM, the GPU, the dedicated GPU. There's also the integrated one. You see it's 6 cores, 12 threads, Fedora 43, GNOME 49, obviously Wayland as well. And this one I was talking about LoRa's, VAEs, ControlNet, etc. So you guys can read this as well. And again, as you can see, this is for stable diffusion. So if you don't have the space, maybe you only have a CPU, I wouldn't recommend running ComfyUI. Instead, run this stable diffusion.cpp. So I'll show you this one as well. We're going to run everything. Don't worry, we'll run everything. So you need to make sure that you have obviously I'm on Linux, so you can run it in a Podman or distro box if you're on a Linux type system. If you're on Windows, I think Mac should be fine as well. I'll prove that as well. GCC or Clang. I found that GCC gives less errors, But because AMD used Clang or a version of Clang to compile ROCm, you can also use the Clang one as well. Just ignore the warnings. CMake and Git. Git is just to clone the, or if you don't want to clone it, you can simply just go grab it yourself. And these are the things you will need. And obviously grab, you see I'm using, you can run the Q3K model. It's a 6B model, but you can run the Q3 as well. So let's actually start from this guy. So we can go to, so you go to llama.cpp, oops, llama, just type llama.cpp, hopefully it comes up in a search. Yeah, see here, llama.cpp. You see this one, it's LLM interface in C++. You guys can read this. I said I went through this earlier today. My throat is getting a little sore. A drink of water. So you can even run it in a Docker. Obviously you can run that in a Podman as well. The container. There's also pre-built binaries. We'll go to the releases page in a second. You can see here, this is tailor-made for GGUF models. And as you can see, you can read all this stuff here, Vulkan, etc., etc. So let's go to the releases page. You can also build it if you wish, but there's no need to. At least for me, because I'm on Fedora. It comes in Fedora. I just install it that way. So go to releases page. So if we go here, you see there's Linux builds, one for Vulkan, CPU, and what else is here? Mac OS. You have Apple Silicon, Intel, and Windows. You guys are really spoiled here. You have Vulkan, HIP means AMD. So this is what I was trying to say. Instead of me, an Arch, if you have an Arch based ARM, sorry, I meant ARM. OpenEuler, I don't know what that is. So what I was going to say is, if you're on Windows, you guys are lucky. I said you can split download and run obviously in a 64-bit system. Except if you have ARM, it's only CPU. What I was going to say is that on Linux here, Vulkan and CPU. Vulkan is fine for, but I found Vulkan a bit, so that maybe because I was using Llama client. I haven't actually tried Vulkan on llama.cpp. What was I going to say here? Yeah, so you see, instead of me compiling this, I can simply just grab it from the Fedora repositories. So there's also a version for generating images and video. It's called stable-diffusion.cpp. I've talked about this several times. You see this one here, stable-diffusion.cpp. You see it supports all the image models, the most common ones, video models, photo maker, image edit. Video is Wan 2.1 and Wan 2.2 right now. The project is still relatively new. And you see GGUF, safe tensors, PyTorch checkpoints, some sampling methods. It doesn't support everything that ComfyUI supports, of course, but I'm saying is that this is definitely the future. I can see it. So what I'm going to do is, let me go to the releases first, and I'll show you this as well. Open up in a different tab. So this is also cross-platform. You see Darwin, that's obviously Mac OS. For Linux, they have the Vulkan and just the CPU. And Windows, again, you guys are very spoiled. You see there's ROCm, there's CUDA, and obviously the CPU stuff as well. And then there's the source code, so you can grab the source code and compile it yourself. So I'll go back here, and where is the build? I'll show you more guides. And there's also a Docker version as well. Where's the build? Build guide, here we go, build guide. So if you build it, it'll be optimized for your system. For example, if you're building it for the CPU, I would highly recommend, don't just build it for the CPU. You build it with OpenBlast. That will speed things up. And then if you have CUDA, you can. This is most likely for Linux, to be honest. And Hippolas, this is AMD GPU, and Musa, this is more Threads GPU. And Metal, obviously that's Apple Silicon, and Vulkan, and OpenCL if you have an Adreno GPU. So all the instructions are here, and this one for Intel GPUs. So yeah, so there we go. And obviously ComfyUI, you guys know ComfyUI, I mean, just follow the instructions there. So okay, you know what, just to be fair, I'm going to type ComfyUI. You can just follow the instructions. So you see ComfyUI here. You can also go to the GitHub page. Let me see if they have the information on the, so let's go download. You see you can download for Windows, Mac, all install. So there's no Linux. Oh no, I'm insulted. So I don't have, obviously I don't have a Windows system. I don't have a Mac, and obviously, so let's go install from GitHub. Okay, looks like it takes me to GitHub, which is what I wanted. So for GitHub, all I did was just follow the instructions here. So what's going on here? So you see ComfyUI does support quite a few. Where is the, so installation, you see there's a portable, this is even portable builds for Windows. Then there's a CLI version and manual install for Windows or Linux. So that's what I'm interested in. You see here, this is another trick. So this answers the next question, is how to prevent the Nvidia stuff from being installed. So when you install, don't simply just put pip. If you're using pip, don't just put pip install torch video, torch vision, and torch vision and torch audio. If you do that, sometimes it might wrongly detect that you have a Nvidia GPU. So don't do that. What you do is, you see, you add this index, then it will download, you see it will download whatever version of ROCm you want. So for example, on my system it's 6.4, so this one would work for me. If you have a 7.2 or something, that's fine. So by the way, AMD does have 7.2 already, and I think even some people have been able to successfully run it on 7.9. Which, yeah, so I'm just gonna wait for Fedora 44 with 7.1. I'm okay with 7.4 right now. The other problem I forgot to mention is that Fedora comes with Fedora 43 comes with Python 3.14. So luckily, as I said, all the stuff that I need are in the Fedora repository for Fedora 43. But there's some things like mgraphx for Onyx runtime. That one hasn't been built for Fedora 43, so most likely that will be it. I saw it in the repository. That will be in Fedora 44, so I have to wait for that one. So I'm taking a little bit of performance hit right now, but I'm saying I'm pretty happy, and because I'm learning. So what that means is that when Fedora 44 comes out, I'll definitely upgrade because it's going to stick to a Python 3.14 as well. So that's going to be perfect for me. And as you can see here, Intel GPUs, Nvidia, etc. So that's ComfyUI. And here's a ComfyUI manager as well. You see the same things, or is the requirements, and then you enable a manager. So I said personally, I don't. Oh yeah, here's another. Thank goodness I scrolled down here. It says for AMD cards not officially supported by ROCm. So remember, my GPU is not officially supported by ROCm 6.4. Try running it with the command. So you have this override. You put your version in there. For example, this is for this 6700 and 6600. And maybe it says some RD. Right, really? AMD doesn't even support the RDNA 2 or older cards. I mean the RDNA 2. That's weird. And then the 7600, you can also do an override as well. And then for tips, it says you should you should try this. This is an export. So this is clearly not on my GPU, and my GPU also doesn't have PyTorch coarse attention. So this do not work for me. However, I found something that works for my particular GPU. Now, I've come across some GitHub repositories where people have been able to run some type of coarse attention. I think the first version, and some type of sage attention for my particular GPU. I tried to compile one, but I think it was meant for ROCm 6.3. It didn't work in 6.4, so I was like, you know what, I'm happy with what I have, so I'll stick to it. So you just follow the instructions and you'll be perfectly fine. Perfectly fine. Okay, so enough talk. Let's go and actually take a look at some of this stuff. All right, so let me show you my folder first. Okay, here's my folder. I have a partition where I just have AI stuff. So as you can see, I have a ComfyUI one. I have the stable-diffusion.cpp here. This is the swap file, as you guys saw. Oh, I forgot to show one more thing. Let me show you what my system is. I've already explained it several times, but some people might not. So my CPU, 6 cores, 12 threads. Memory, as I said before, you have 32 gigs. 4 gigs are used by the integrated graphics, so there's only 28 gigs left. But I said you can, even right now, I'm not running any AI or anything, but you can see I'm using the system. I said I have multiple OBS, Social Stream Ninja, a bunch of browsers open, and multi-streaming and FFmpeg. So there we go. So I'm already using some RAM. That's something that usually I say I have about 21 usable RAM, which is correct. You see, I'm already using the swap. I think some of this might have been from the earlier today when I ran something. Well, there we go. So I'm gonna take you. Where are you? So I'm gonna close this. Well, I'll close it for now. All right, and then I have what else do I have here? I have my model. I put my models here. Right now I have this model. You see, it's a Q330B AB instruct 2507 UD. You see, it's a Q5K XL, meaning extra large, and you can see the size of this guy is 21.7 gigs. So that easily fits in my 32 gigs VRAM GPU. And then obviously ComfyUI. I downloaded the models manually and I put them in, where's models, here we go. I put them in the proper places where there's checkpoints. What else is it? Diffusion models. You can see I have the Wan 2.1 fun in paint is 1.3B. That one is at FP16. I've also tried the this is just a regular one, FP16. It's also pretty small. So that one easily fits in the GPU, that's why it's there. The other thing, oh yeah, I have upscale models. Oh, that's latent, sorry. LoRa's, I do have a couple LoRa's here. Actually, yeah, I do have 2 LoRa's. This one for the Z image turbo, and then this one for the 2.1, 1.3B distill. What else we have here? I don't have any photo makers yet. Text encoders. As you can see, quantized 3 Q8. You see the size of that one, 4.3 gigs. And then I have this one, which is a Q4K XL 2.5. And then this one here, this one I believe is for video, 3.7 Q4, and then the Q8 as well, it's 6 gigs. So just to squeeze everything in the unit. This is where my GGF models are. This for an upcoming tutorial. And you see the 1.2.1, this one here is pretty small, it's literally 1 gig. I was just looking to see if it would be faster. And the Q8, there's not too much of a difference between those two. And here's what I was trying to say. You see this, this is the high noise, it's 10 gigs, 4-step. And this one is also 10 gigs, you see? So now you might say, well, that's 20 gigs. Yeah, remember, you also need to put a, what do you call it? Text encoder, you need to put a VAE, and you need to leave some room because when it's working, when it's generating the images, which are basically just pictures, it needs some room as well. So I want everything to run in the on the GPU, so that's why I can get something bigger. I would love to be running a Q8 because I know that would be faster, but I'm saying is that it's gonna, yeah, I won't have, I'll get the out of memory errors. Then I've been fooling around with this one here. This is 12 gig, it's an all-in-one. And what is it? What do I have 2 of them? One is a Q8, what's the other one? One is a Q4. So you see the Q8 one is 18 point. So this one I was thinking, what's the point? Because it's basically the same size as the low and high noise. So yeah. And then obviously the Z image turbo. You see I have the Q4KM, and then I have the Q. Both of them easily fit inside the GPU. I could probably even try the FP16 if I wanted to. But I said I know Q8 is the fastest, so that's why I picked. And the code is very, very nice. And again, we have the upscale models. You can see the ones I'm using here. I had to get this one, the X4, because for some reason when I was running stable-diffusion, it would not take this one, the 2. So I had to use the 4, which is fine as well. And VAE, as I said, this is for encoding and decoding. You see, this is the one for the flux type models. And you see I have this one. So this one has, I think, some BF16. I think this to do. So I got this one, and this one you see FP32 and FP16 because that's what my GPU supports. And then this one is for the Wan 2.1 models, and also Wan 2.2 14B. For some reason, only the Wan 2.25B supports the Wan 2.2 VAE model. And this one is a tiny encoder. I used this, I can't remember what it was for, but man, that just also made things really fast. Yeah, so, and then approximate this, sometimes you put, oh no, sorry, I made a mistake, sorry about that. This is where the tiny encoders go. This one, so you see, you need to get an encoding one and a decoding one. All right, so that's the models. And anything else? I think that's all I need to show you. So the GPU I have, it doesn't come with any cooling, so I need to cool it. So what I do is I have a 3D printed fan shroud with a 40mm fan. So I do have a script here, as you can see, GPU case fan, and then I have a systemd service. The reason I don't run this, I'll tell you why, is because when I'm running especially AI stuff, the temperature, it just jumps up so quickly. So I don't want to fool around with this. So I say, you know what? I'll just control it manually because it's loud, especially when on the higher settings. So I'll be here, so I can. It will know me enough that I can switch it off. So I'm perfectly fine running it manually. So I'm going to start this application. I'll start it in the command line. Unfortunately, I need to run it as a root user or a super user admin. So this is the cooler control. I'll show you what that looks like. Well, actually, I can pull it up right now, so if you guys want to see it. Okay, one. And we're going to go to system fan 2. Here it is. See, by default it's around it's just below 3000 RPM. When I run the AI stuff, this is the dedicated GPU. You will see the temperature rise up very quickly. As I said, I control it manually. This is the integrated one here, so I can minimize that one. I don't need it. And this is the Wi-Fi card. This one doesn't come with a fan at all, and that one doesn't get too hot, so I leave it there. So you can see on so-called idle, it's running at it's about 43 degrees because it's winter here. In summer it's usually around 45 46, but it's, I said, when winter, Canadian winter here, so that's perfectly fine. And yeah, so for example, this the CPU here, the CPU one, that one is I control it by fan, what do you call, fan profile in the BIOS. And you'll see this one also, the temperature does get pretty up high when the CPU is actually being used. So meaning that I'm saying controlling it manually is what I want. Of course, I can also control this manually. I do have the sensors here, but that's fine. All right, so now I'm going to go to stable. So you see stable hyphen diffusion. You just do a git pull, and then you can just build it. So that's what we're going to do here, and I'll show you how I installed everything in the build folder. In the bin here, you have two of them. I haven't tried the server yet. I just run the command line here. So that's what we're going to do, as I said before. And you see these are some of the images I generated before. I was trying to use the LoRa's and what was that thing, the pose, to put my book, this Recession Business Blueprint. I was trying to put it here, but I wasn't able to do that. I think maybe I'll do that in ComfyUI now that I'm more comfortable with the ComfyUI stuff. So I even, you know what was happening? It was messing up the book. So then I started using masks. I said I've learned a lot since last year. So I was trying to do mask, meaning that I don't want it to change my text or anything like that. But it will, this Z image turbo, it would not listen to me. It will still try to change it. So it might be also because I was probably using a Q4 model. I think I just tried the Q8. I'm not too sure. And you see, I was able to generate videos also. Yeah, so I was able to generate videos. The Z image turbo is still really good because it's fast. I like that. All right, so let's yeah, so this is the one we're gonna do. So let me pull this out of here. Okay, I'm gonna put this one here. Okay, go back to the command line. Here we go. Now, I said I'm on Fedora, so all I did was I did sudo dnf install ROCm. That is all I did, and that installed a ROCm, meaning the drivers for the AMD and everything. And plus, because I use Blender, Fedora for some reason hard-coded. I made it a dependency. ROCm, even though I can't use it because Blender removed OpenCL for my particular GPU. Anyways, so it kind of works out for me. So this is another reason I don't want to use DistroBox yet, because I'm going to have like 2 versions of ROCm. I'm saying I'm space limited. All right, so let's go to, what should I show you here? Okay, I'll run some commands here just so you guys can take a look at. Let me see, I'll go to my AI thingamajiggy here. What are we gonna do next? Okay, so let me see some information. Yeah, I've already talked about that. I explained how I removed the swap. Oh, Vulkan tools, if you want to use Vulkan, let me zoom in here. So for Vulkan, it's just sudo dnf install just Vulkan tools. That's it. And then you can type Vulkan info summary. Zoom out a little bit so you can see here which GPU is mine. Remember, I have 2 GPUs. One is the dedicated graphics, one's the integrated graphics. You can always tell which one is which because the Vega 20, that's the dedicated one. So this is the dedicated one, and this is the integrated one. Yeah, it even says so right here. It says so right here. All right, so to test to see if it's actually working, obviously it is. You can just type vkcube, and you can see this is running under Vulkan. Okay, and you see I'm on Wayland. To prove I'm on Wayland, it does work. So as I said, Vulkan is the future. I really hope that it's cross. What do you call it? Works on all the hardware. All the GPUs, CPUs do support it. What I'm really hoping is that so sometime in the future they actually support it well, so it doesn't become like another OpenCL, and that way you can obviously you can buy. You don't have to, it won't be like planned obsolescence if you have a GPU or anything like that. That would be really nice. All right, so obviously you also install the. I'll show you how to prove that I've installed the Vulkan drivers and the Mesa drivers. Again, I'm on Fedora Linux, so let's paste this command in here. So you see it's I'll zoom in. So it's a Mesa -Vulkan drivers. That's it. It's installed. You see, it shows it's installed. So that's how I know I have Vulkan installed. Now I'm going to show you my batch RC file. Okay, so I'm going to scroll down. The most important stuff here, you can see this VDPAU. This is for from hardware decoding. This is for both the old Nvidia and older AMD GPUs do support it, like mine does. And then this is the libva. This is mostly what Intel does, but on Linux, AMD also supports this one. So this is for video hardware encoding, like if you want to use H.264, what's the other one? H.265. and AV1. And Olama, so I put the Olama models in the, as you can see, /mount AI models. And for Hugging Face, I also put in the AI partition. And this is the ROCm spoof hack. This is very, very important. So as you can see here, the override, this is my GPU 9.0.6, and then you need to put, especially if you're using DistroBox, you need to put this one here. And then for ComfyUI, you need to put this one as well. Yes, even though I don't have a CUDA device, because when all this AI stuff was created, they basically assumed it's only going to work on Nvidia devices. So they still use some of the names, instead of calling it GPU or something like that, they call it CUDA. So just make sure you put that as well. And then I tried this mopen stuff. I found it a little bit annoying, so I decided, you know what, I think that's why I commented out, and I just let it use the default. And some of this stuff, it complains about in ComfyUI, even though my GPU doesn't support it, but I put it here just to make it happy. All this stuff as well. So yeah, that's I put this stuff in here. This was all recommended from ComfyUI, especially when you run out of memory or something like that. So I put it there just to stop it from putting all those warnings. So that's it. The only one you need, by the way, is this one right here. This one, if your GPU is no longer supported. So you have, remember I told you my GPU last officially supported by AMD is ROCm 6.3. So I'm using ROCm 6.4. So I need to put this override. This is only for ComfyUI. There might be some others as well. I'm guessing like Easy Diffusion. What's the other one? SD Next. All of them do that. Now, in case you're wondering why I'm using ComfyUI instead of SD Next or Easy Diffusion, is because to this day, at the time of this recording, they still don't support properly Python 3.1 for ComfyUI easily. That's why I'm ComfyUI. Okay, now what else do I need to show you? Oh, I need to show you some ROCm stuff. Just a second. Where can I show you the ROCm stuff? So I can type something like hip config space version. You see, it's ROC. So this is a further proof that I'm using ROCm 6.4.4. Before this used to give an error. I'm pleasantly surprised that it does not today. And yes, I think that is there anything else I need to show you guys? Just thinking here. Oh, you can also install, for example, Python 3.14 if you wish, but actually not 3.13 or 3.2. That's all in the repository. But I said I don't want to have multiple versions of space limited as well. Okay, so I'm gonna put some commands here which I did to install. Let me clear this. I'm gonna put some commands which I used to install ComfyUI. So what I did is I searched for what's in the repository. I put DNF search torch, and I was pleasantly surprised that, let me zoom out here. You can see it has torch audio. What else does it has here? The torch SDE. Is that it? I thought it was just a second. Oh yeah, torch vision. What's the other one? Torch audio, and torch vision. So you see, Fedora already has this package. These are the ones that I installed. So I installed them this way. Then I also installed some other packages. I will show you what they are. So then I ran this command as well, paste it. You see I also installed AIO, HTTP, Python, all these Python packages as well, and this NumPy, I installed that. So then what else did I install? I installed a whole bunch of stuff, including Hugging Face. So yeah, like I installed quite a lot of packages. Now, let me show you some other stuff here. I'm gonna zoom in. Oh, not too much. There we go. Clear this. So this is ROCm. you can tell that what GPU is going to be using 225 watts of power. Obviously, the dedicated one. The integrated one only uses very little, so you can tell the integrated one is using very little power. So GPU 0 here is the dedicated one, and 1 is obviously the integrated one. It even says right here, max graphics power is not supported. So I could overclock this, if you will. Like, for example, you see right now it's only using 225 watts. I can increase it to 300, but I'm perfectly fine with that. And I'll show you one way to do it is you can check your BIOS, and then you can run this command to set overdrive to 300. So it's asking me for my which I'll put it in there, and you see energy, secondary die check, unexpected data. So it says I cannot put a value greater than 225 watts. Obviously I have to check my BIOS in order to increase it. So that's one way, but I'm saying I'm perfectly fine with it. It will give you anywhere from like 5 to maybe 20% increase, but as I said, there are other ways you can do other things as well. So another thing you can do is to check how much VRAM. For example, if you buy this type of GPUs used, you want to do something like this to check to see how much VRAM it actually has. And you can see it actually has 32 gigs of VRAM, and the integrated one only has the 4 gigs, as I said, the one that it does reserve. Okay, I've explained the hack, and I think that's it. So if you notice, what people will tell you is, the people are going to tell you to, let me explain what I'm getting out here. Make sure, I'm going to show you guys this, make it clear. I'm going to show you guys this one here. Let's go back here. So what, let me actually put it always on top. Always on top here. Always on top. So what they're going to tell you is to create a virtual environment, right? If you're running ComfyUI, they'll tell you to do this, and you see to create this, then they'll tell you to go inside this one. However, that's perfectly fine. You have to use pip to install everything. So because Fedora has everything I want, so let me actually remove this. So what I did is I used system, the repo packages, and I'll show you. You can still create your virtual environment, but what you do is you add space system site packages. What this will do is it will still create your virtual environment, but it's going to use the site package, the system. So meaning that it will pick up ROCm, everything that was installed by Fedora, all the Python packages, pick them up that way. So that's the one I'm using for my ComfyUI setup. So that's a nice little trick which I found as well, because I was thinking, hey, if Fedora has it, why not? So I was curious about this because the first time I ran Easy Diffusion, I never used a virtual environment. I was just using pip and was just installing it kind of system-wide-ish anyway. So there we go. All right. Now, we'll come back to ComfyUI. Let's go to stable-diffusion. So if you remember where stable-diffusion is, it's the one here, and we're going to go to the build folder. So I'm just going to go to stable-diffusion. Now, because I already cloned it, all I'm just going to do a git pull to get the latest version. I haven't run this in a while. Yeah, so there's some, you can see I was about three behind. So there's been a bunch of changes, most of them on the weekend. So I've grabbed them. But remember, there's also submodules, the GGML. There's only one time I've done this where there was actually an update, but I still run it every single time. Yeah, there's none. Okay, that's probably fine. Then you go to the build folder. This one you see here, and then so I follow this. These are the instructions right from the stable-diffusion repository. So let me clear this and paste this command. So you see it found ROCm in /user bin /roc info. Most people will probably tell you, oh, it should be in the opt folder. No, I said this one makes Fedora pretty awesome. And then what I do is, you see it found my GPU GFX 9906, and then what I do, I'm just going to use CMake, and then you can see if you read this, it's going to use heap blast. So that's it's not like OpenBlast. That's specific to the AMD, especially the GPU. So that'll make it faster. The version, the commit, that's perfectly fine. Obviously, I have a 64-bit system. There's a GGML. It's also going to include the CPU backend. Okay, I don't know why. And then it's what is it here? HIP and HIP plus. We talked about that. GGML. This hasn't been updated in a while, and that's it. So now all I need to do is just to build and then release. I'm not doing anything special here. This is all from the stable-diffusion GitHub repository. See what I was trying to say, because I'm using Clang here. Clang has what do you call it? Clang has the Clang Plus or whatever you call it. It does have some warnings, so they're perfectly fine. But I said if I was running GCC, it would be finished. It's very quick, so there's no excuse not to run this. Whether you have a CPU only, obviously this compiling doesn't run on a GPU, it just runs on your system. It's very, very fast. So I'm saying this application is amazing because this is the future. You can also run it on Vulkan. I didn't enable Vulkan because there's a bug where Vulkan does not use more than, I think, 4 gigs of either a text encoder or something like that. It can't pass more than 4 gigs of something at once. So once they fix that, I'll probably see, because especially for the AMD, there's some cases where Vulkan is actually faster than ROCm. I haven't come across that yet. Well, no, that's not true. I lied. I apologize. I've noticed for when I run this, at least in the past, the sd-diffusion.cpp, Vulkan loads the models really, really fast. No matter the size, it loads them really, really, really fast. So that is actually a good thing. I don't know what algorithm they're using, because Vulkan is supposed to be cross-platform, so meaning that they don't say, okay, this is for AMD should be faster here. They try to make it as generic as possible, but even that, it was really faster than the way AMD loads the images. Anyways, so we have here, and now I can actually run something for you guys. Let me see what I can run. I'm not sure what model. I think I only have one Z image turbo model. I'm trying to see what I can let me see if I have something I can run. Yeah, because there's been a bunch of differences. So let me see. I think I run this one. Okay. Sorry, give me a second. I need to go back and check what models do exist and which ones do not. I haven't updated this in a while. So let's go check it out. Let's go to the AI folder, go back to models, and ComfyUI, and go to models, unit. So I have this one, Q8 and the Q4M. That's Q4M. Okay, so I think I'll run this one. Okay, so prompt. I think I'm putting prompt here, and I'm gonna run. You see, I can run both of these. You know what? Let's actually run both of them, and we can compare the quality. There should be really no quality. There should be no quality drop. Oops, that's the wrong one. VAE. Okay, here we go. This should be unit. make sure I have the VAE text encoders. Let's go check the text encoders. I can also use the tiny, oh, it's not here. Which one did I use? The Q4M. Oops, I don't have the Q4M. I have this one, which is the Instruct Q8. I don't know if this is the same UD. Okay, I'll try this one as well. Okay, so I'm going to check. I'm going to call this Z image offset tutorial. Yeah, tutorial is perfectly fine. So it's going to take the mayor of Toronto and then it's going to do some weird stuff. So I'll explain the command as well when we run it. So here we go. Let me clear this. Okay, so oh, I can't believe I'm running 20 steps. That's kind of okay. So it says here that from the bin/sdcl. Okay, so diffusion model, it's gonna grab the Z image turbo, and then the VAE. I know that one does exist. AE safe sensors. Then the model itself is gonna be did I do this correctly? I'm confused here. Oh, yeah, the text encoder. Okay, so the text encoder is this one here. This Quen 3B UD 4KXL, and it's going to be smiling, photorealistic, I said in a white background, overlay text saying hello Toronto. Steps 20, and the width is going to be 512 by 512 because the image from the current Toronto Mayor Olivia Chow is 512 by 512. And Z image turbo, of course, is the image turbo. So I'm going to run this. If we look at the temperature here, it should not bump up too quickly. I think I can run this. The 20 steps gives me a little bit of concern, but we'll see. Yeah, we'll see what happens. Okay. So it's just loading the stuff onto the into the VRAM. Now I haven't optimized this like I did with the video, so I'm just waiting for this temperature. You can see how quickly the temperature goes up, right? So I usually get concerned when it's about 70, right? I'm hoping it goes quickly enough. And you can see, even though I put 20 steps, it's actually not going to do 20 steps because I've done this several times. So using mopen, meaning that it's smart enough to know that, and it finished. So 20 steps, it finished. So the temperature is pretty fine. I don't have to do anything as well. So that's why I love this model. So let's go back up here and I'll explain some things to you. So even though this model was a it says right there, Q4KXL, it still has some, as you can tell here, it still uses that BF16, but it's only 28, so that's not a big deal. It has a Q6, obviously my GPU doesn't support it, but that's fast. This should be fast enough. And it has, as you can see here, Q4, fine. F32, perfectly fine. My GPU supports that one. You see, there's no 8s here. So yeah, that's perfectly fine. I'd rather this have been integer 8, but obviously it needs some floating point, so that's perfectly fine. So this is okay. I've never seen this before. Integer Q4X. Okay. All right, whatever. See, and you see, so we took an initial image, and then it's supposed to use that image, but we'll see what it looks like. So let's actually go take a look at the results and see what it looked like. So it should be at the bottom somewhere here. ZZ. Is he at the end? Somewhere here. Why can't I see it? Oh, it didn't come out well. So something went wrong. Most likely it's the text encoder. So let's see if we can figure out. Sometimes it will tell us what went wrong, and then we can take a look at it. I'm going to assume that it didn't like. It probably didn't. I think it didn't like this text encoder, so I might have to use the Q8 one, which I will do in a second. So let's see if it gives us a hint of what happened here. No, it doesn't give us a hint. Okay, so let me try. I'm gonna run this again, but I'm gonna use the different text encoder. I'm gonna use this one. I believe this is the. Yeah, I believe it's Quen. Let me just double check to make sure my AI is a Quen. Okay, so maybe I used the wrong one. Sometimes they're a little picky, so I'm gonna use this one here instead, and we'll run that again. Include this. You can see, let's see, anything different here. Look at that, F32. A little sip of water. Check those temperatures because they can jump up very quickly. Oh, I might have to switch this on. Let me just I'll put it at 35 just in case. Oh, as long as it's slow, if it stays below. Okay, it's success. One of the things I kind of dislike about this is when it does this, it doesn't tell me what's going on. So I don't know if something went wrong. I just have to look at the. Oh yeah, it's still black here. So I don't know what I'm doing wrong. I don't know what I'm doing wrong here. I'm probably missing something. Sometimes if it can't find something, it will just continue instead of saying, oh, I can't find the device. But you know, let me try something simple. Let me, instead of the, no, that doesn't make any sense. Why is that not working? You know what, let me go to these, let's go check that out. Let's see, maybe I made a mistake. I don't think so. Leadjet. I could use Vulkan. That'd be hilarious. So let's go to, where's the Z image turbo? Z image, here we go. And so I'm gonna grab, yeah, see, you can even, so here's the quality. As I was saying, you can see this is a Q3 and it's actually very, very good. So I'm gonna copy this and compare to see the one I have, see what I'm doing wrong. It's the instruct I have. Okay, so I'm gonna modify my modify it a little bit, and I'm not gonna use an initial image. I wonder if it's because I put 20 steps. I'm gonna remove the 20 steps as well. And what I'm gonna do is see, I think diffusion or whatever, that doesn't matter. I'm gonna move this guy here. Okay, I'm gonna run this again and see what's going on here. Text encoder should be fine. VAE should be fine. And okay, so while this, I'm going to run this again. Okay, this time I'm going to leave it at 35% because I don't want it. So while I investigate and see what went wrong here. So you can see it tells you how much VRAM. I know that as well, so that's actually pretty good. Okay, so this finished. It's still, well, it's still black. I don't know what's going on here. Okay, I'm gonna try. It's so weird. It's so strange. VAE. Do I have a turbo? Let me see if I have a turbo, a bigger model. Okay, I have this Q8 model. So instead of using this one, I'm gonna use this big model as well, and see if that fixes it. Yeah, it's definitely black. You see, it's using the Euler method and the get sigma is a discrete scheduler. That's the default. I'm not sure why it's not outputting something. Black again? Yeah, it's black again. I don't know what's going on there, but you normally it doesn't do this. Like you can see, I did generate images before. I do not know why it's just being a pain today, but it normally does work. I have no idea why it's not working today. So I'm just going to. This is another reason why I also moved back to ComfyUI, because sometimes I get this and I can't figure out why, because you guys saw I did update, I compiled it. Yeah, sometimes it's just a pain, and sometimes the models also change. Maybe something changed here and I have to update the models, but these models do work perfectly fine in ComfyUI. So let me try a video. Video should be fast. Let me try a video generation. If video gives me the same problem, then I will know something is wrong with it. So let me see if I can pick up a. Oh, I do have something here. A lovely cat. Let me try one more. A lovely cat. I think I do have everything here. QM and yeah, I do have a lovely cat. So this one should work. Okay, so let's check this one out. Because I have it right here, so it's lovely cat. I just want to change the tutorial. I'll call this one See image turbo tutorial PNG file. There you go. If it, I'm actually put this at 35. This should be quick though. It should not even. So this one, if we go back up here, I put it at 4 steps, and the height is 1024. The width is 512, and this one it just says a lovely cat. So this should be fast. It's only 4 steps. And you can see I did okay, there we go. What did I do wrong? Quen 3D. I don't understand what the difference is here. VAE, text encoders. Okay, I don't know. I don't know why that wasn't working before, but as you can see, yeah, you are able to generate images. Yeah. Oh, let me turn this down. Sorry about that. So here's the result. And this remember, this one was the Q4KM. You see, nice, very, very nice as well. And you can do other fancy stuff like holding a sign or whatever you want to call it. So there we go. Maybe just likes cats. All right, so this is stable-diffusion. If we see how long it took, how long did that take? It says it took 2.94 seconds, so less than 3 seconds. I was able to do this. And remember, the more you run it, the more it will be cached. It will be much faster. You can also put cache. I didn't. There's no speed stuff except for 4 steps here. So yeah, so this works extremely well, as you can see. You can also do videos, as you can see here. Oops, I forgot. I've also generated videos, as you can see here. This was a 2.1 1.3b. I did generate a bunch of videos as well for, yeah, so you're able to run, yeah, so without any Python stuff. So that's one way if you especially if you have a CPU only, I definitely recommend running stable-diffusion. So that's stable-diffusion. Now let's go to ComfyUI. And get out of here and here, and then go. Let me clear this. CD ComfyUI. ComfyUI. And same thing. Do a git pull. And you see, there's been a change. There's been one change here. However, I need to go to the custom nodes, and I also need to pull in some stuff from the custom nodes. So I have a for loop here. It goes through all of them. I read this earlier today, so everything's up to date. So there's nothing for me to do. So let me just get out of here. Then what I do is I'm going to start my source at the virtual environment, bin activate. Okay, then I just type pip -r install requirements.txt. There we go. Now I want to show you this to prove that it's using the system-wide packages. So I want to go, let me zoom out a little bit here. I want to prove to you that I'm using system-wide packages. You see here, here's a perfect example. You see this one here? It's using Python 3.14, so it's system packages. You see, it's using from Fedora. So this one, CPy, Pillow, this one here, YAML, torch, remember the SD, see it says /user/lib, it's system packages as well. I'll zoom in a little bit because some of you guys can see this. And you can see here, Torch Vision is also a system package. Torch Audio is also a system package. So a lot of this on the Fedora system. The reason I did this as well is so that if I wanted to test out, for example, in the future, like say SD Next, ComfyUI, of course, what's the other one? Easy Diffusion or something else. I already have the system packages, so the VNE will be much smaller. I said I don't have space. If I had space, I wouldn't care. I would have like several versions. So some packages are not in Fedora, at least in Fedora 44. So for example, this one, IO HTTP, that's the system package. Some others which are not system packages, obviously you see it will tell you the location. It's in the virtual environment. All right, now everything is up to date here. So then instead of typing python main.py, right? What I do is I forgot one very, very important thing. So sometimes if you need to install especially a custom node, instead of simply just typing the pip install as -r requirements.text, what you can do is you can either open up the requirements or text file and remove anything that has to do with Nvidia. That's one way to do it. The other option is there's something called, let me see if I can pull up an example here and I'll show it to you. Sometimes if you once you install these packages, they tend to bring in a whole bunch of stuff which you do not want. So the way to, so what you do is at the end, you just type --no depends. This is the trick right here. --no -depends. This won't pull up more dependencies. For example, if it depends on Nvidia stuff, when you already have your AMD GPU. So those are type of tricks I said I did learn when I was running this. All right, so Python main.py, and I said I know my GPU, so I will show you what has worked for me so far. I don't put the close attention and stuff because the GPU doesn't support it, or I haven't built it yet. So I use chord. You can use --use -chord -cross -attention. That one is very common on other GPUs, so even though I have an AMD GPU, that should also work on your Nvidia or any GPU that's no longer supported. And then this one here to reserve VRAM, this one set to true. This will prevent it from also getting those out of memory errors, especially when you're running super large models like the LTX2, which everybody's all hyped up about. And then here I put the cache to none. The reason for this is because to speed things up, what ComfyUI does is, if you notice, the first time you run something, it's a little bit slow, and the next time it's faster. That's because it will cache the models and everything into your RAM, or if you have enough VRAM, it will do that as well. Now the thing is, if you're, as I said, if you're running some large model, I don't want those stuff cached, especially for example this one where you have the low noise, high noise. I do not want that feature. So I'll show you how you can make this faster anyways without when you put cache none. So when this is running, we'll look at some of the output. Another drink of water. Just be patient. I think there may be some stuff still cached from earlier today because I haven't turned off the workstation so far. Alright, so let's see. Let's go check the system monitor. I'll bring that up. So you can see here a 1.1 gig. So this is clearly ComfyUI stuff here. There's no reason for you to use the swap. You should just be using this. That's perfectly fine. Where am I here? I don't need this. I don't need this to be on top anymore. Where's on top now? Okay, so we're gonna make this smaller. That's fine. So now this is ready. So before we go here, you see loaded up all the custom nodes. You can see, for example, GGUF, obviously, KJ, I think, yeah, LTX video, a video helper, and this one is very, very important, layer style. This is the one that allows you to get rid of some of those, some of the RAM, and some of the stuff that's being cached. This will speed up your workflow. And so this is the part I was trying to tell you here. So you see for my AMD GPU, we have two options for this Onyx runtime. There's this ROCm execution provider. This has been removed. And then there's this one, mgraph execution provider. This one is not in Fedora 44, but it will be in Fedora 40. Sorry, it's not in Fedora 43, it will be in Fedora 44. Okay, so what else? That's it. That's basically all I need to show you. See, it detected my GPU as well. You see the VRAM, 32 gigs, and the RAM is only 28 gigs, as I was telling you before. And I said, but as you can tell here, I don't really have 28 gigs because I'm running other stuff. But you see the GFX 906, and you see ROCm 6.4. So when people tell you, oh no, you can't, just because this is another great thing about running open source software. Some smart people will be able to figure things out, workarounds, and you see this. This is why. Now, could you imagine if AMD was this drivers and stuff were proprietary? Nobody would have been able, I mean, some people could maybe hack it, but nobody would have been able to figure out, like, just put the tensor files back and you'll be able to run. Otherwise, this GPU I have would have been in the dustbins, right? So yeah, that's perfectly fine. Sometimes you might see some CUDA stuff. You see here it says device 0 is a CUDA. Remember I was telling you about CUDA, so it's actually an AMD Radeon graphics. Okay, so let's actually go to this URL. It's 8188. So I should I'll do it here. Okay. Okay, there we go. So just type in 81. You see, I've run this several times, and then we have. So you see here, I have this Wan 2.2 14B. What I did was this one only runs on the low noise model. As you see, I'm using the GGUF loader. You see, it's only the low noise. Then I have the clip loader, also GGUF. You see, I'm using the this text encoder, and then we have the Wan 2.2 VAEs, and then here's my start image. So if you take a look at the start image, here it is, and then my prompt. It's a claymation prompt. You guys don't need to see that. Everything else just stays the same. There's one little caveat I did. You see down here, I dropped the resolution. The width I made 416, and the height I made 224. Now you might say, oh my god, that's why you're able to generate videos so fast. Oh, I have a trick. What I did was, you see, I used the upscaler. I used the upscaler and I scaled it up to 1040 by 560. So if I put that in the initial one there, it will take a very long time and I would run out of memory. Okay, so because I remember I told you I don't have enough RAM. So what I do is I just drop the resolution and the upscale over here. Now I'm gonna run this just to show you guys how quickly it is, and you see it's only 4 steps. And is this the distilled one? I'm not sure. Let me just make sure if what model is this one? Yeah, it's just the low noise, the Light X 2V 4-step model. And then you can see the settings here. I'm using Euler Ancestral and better for the scheduler. And you see just 4 steps. I'm using the K-Sampler Advanced. This if I was using two case samplers, this is perfect, because then the next steps after that will go to the second one. Now here's the trick to save RAM. If you're low on RAM, and especially VRAM, you see this layer utility purge VRAM. So this purges it, and then if it was going to another case sampler, you would have more VRAM to use. Okay, and then upscale goes to create video, and then the output. That's it. So let's run this. Actually, you know what? Let me bring up a clock just to see how long this takes as well. And I'm going to put this on top so we can see how long it really takes. So I'm going to hit run here, and I'm going to hit start so you guys can see how long it takes. I'll put this here. Did I hit run? Is it running? Okay, it is running. So this one, I'm going to put it at 55, and I'll tell you why I'm going to put it at 55. Well, I'm going to wait until it starts going up. The reason I'm going to do that is because I found that when I put it at 55, it actually runs a little bit smoother and faster. So I don't know what step it is right now. Is it actually running? I'm curious. I should zoom out and see what it's doing. Let me zoom out and see what it's doing. What step? What is it doing? Oh yeah, it is running. It's okay. There we go. It is running. 48. Yeah. So the temperature just went up. So I'm gonna hit this guy to start, and it's been about a minute. And we can also check the command line if I remember where the command line is. We'll check the command line as well. So put this guy down here. What is it right now? Oh yeah, now it's in the case sampler. It's doing the case sampler, then it's gonna purge it, and then it will do all that stuff. This one is gonna take just a little while. And remember, I have so much stuff going on, including this guy here. I forgot about this one too. So right now it's mostly just using the CPU. It's not even using the GPU, but it will come back to the GPU in a while. I believe it might be loading the model, or the decoding or something. I don't know. It's not decoding yet. It's okay. It's in the sampler step. So let me put this. Let me put it here, and let's go to the command line and see what's going on. So if we go to the command line, this ComfyUI. Yeah, this is ComfyUI. You can see here. You see it loaded the model. See, it says I still have 19. It hasn't. Looks like it doesn't load the model yet. Oh no, it does, because I forgot I have 32 gigs. I was thinking 24 gigs. So the model is there, and you can see FP32, Q4. Even though it's a Q4 model, it's also Q6, and this one, the BF16. I said this is my Achilles heel here. If this wasn't here, it would be much faster. But at least it's running. It's done one step. And we just have to wait. The reason it's slow is literally because of this. I think it's called bifloat, or binary float. Yeah, if this wasn't here, if it was just F16, this thing would fly. It's only 4 steps, so this is super slow, 37.62 seconds per iteration, but we're good. We're fine. You see it's now 50%. So if you want to read all this other stuff here, you see this Q8, and then F. So this is perfect. This is perfect. Now I wish I was able to run this model just on my GPU, but these models are pretty big, so this is perfect. This is perfect for the GPU. Because it supports floating point, obviously 32, and integer 8. So this is perfect. This one here could be okay if I didn't have this little guy right here. This is the reason why it's slowed down here. Alright, so it's about 75% down. This is the steps, and then it will do the decoding. And so I'll go back to. I'm gonna go back to ComfyUI, the UI, so you can see where it is right now. It's still in the K-sampler step, as you can see. Oh, let me put this down, maybe it's a bit better. Yeah, that's just perfect. So it even says right here it's in the K-sampler step, 75%. You guys saw that. So once it finishes step 4, there we go. It's gonna speed up now. You see, it's in the decoder. Surprisingly, I was gonna put a tile decoder to make it faster, but this actually works extremely well because remember the resolution is pretty small. Watch how quickly it goes through the upscaler after it finishes the decoding step. Right now it's, yeah, see, right now it's upscaling, meaning that it's done. Upscaling is really fast, so it takes maybe just a few seconds for upscaling. And there we go, done. It's done. It's done. Oh, I forgot to pause this. I think it was about 5 seconds. Put this back down to 2. So that is pretty impressive, right? And just to show you, let me show you how impressive this is. I didn't show you some of the settings. So you see, it's 81 frames. So all of those frames have been upscaled to 1040 by 560, and here's the quality. Isn't that awesome? So that's 5 seconds. So we have a 5-second video in 5 seconds. That is really amazing, and that's a huge model. It's a 14B image to video, low noise, right? So as I said, I don't really care about the high noise and all that because my character is a claymation, and this is what I'm going for. I'm not going for human realism. So if I play this, right? So there you go. You can have a lot of fun with this. Yeah. So now I wasn't even paying attention to this right here. So let me show some of you guys this. You see the memory. I didn't use my memory, and I still use some swap. I don't know why it's using swap, but anyways, the point is, I'm very happy with the result. It does what I want, and I don't have to worry about worrying. So I said my problem is the GPU is fine. I'm very limited with the amount of RAM I have. If I had more RAM, or if I had a faster storage device, I wouldn't be worried, but I have to worry. So that's why I use the quant size. Obviously, I'm happy with this quality. Very happy with it. Let's play it one more time. Yeah, there we go. Yeah, so the reason I wanted to do this is, as I said, every time I go into the hoop coop, in order to clean out the hoop coop and give the chicken some supplementary feed and water, they always crowd the doorway and they get in the way. So I wanted to make something, I wanted to explain it in a humorous way. So that's why I decided to, I said, hey, let me use AI for that. Alright, so this is the video to image, and now I also have some other, this one is a text to video. This is the one I tested as well. So this one I'm still testing. This is the all-in-one, I think it is. Oh no, this is the Wan 2. Oh, this is a Wan 2.1 1.3b model. So I'm torn about this one, because now that I'm able to get videos, as you saw, it's actually less than 5 seconds. It's because I'm doing all this stuff. It usually takes about 3 seconds to generate that 5-second video. The reason it took so long today is because obviously I said I'm running so many things at the same time. But if I wasn't, it's actually much faster because there's more of the CPU to go to it. However, so this model here, the 2.1 1.3b, I'm not even sure why I have this one, because I'll explain later when I show you the other results. And then I have this one, so I don't need this anymore. This was a fun one. What I tried to do is I tried to use the Z image turbo to generate images and then animate them. For example, this one to this one, and then I was going to generate videos that way. But I said now that I can generate 5-second videos, it's actually faster than this and faster than this. So I don't need this anymore. So I think I might get rid of it as well. So some of the things I did learn are very important. You can see because the model is pretty small, I was able to use a larger text encoder. You see it still uses the Wan 2.1 VAE. It has the clip vision here, obviously negative prompt and positive prompt. The vision encode, 2 images of course, put them together. Then what did I do here? Oh yeah, there was this one. I think I added this one just to speed things up. That node, and then the K sampler. I think that's a default K sampler. Yeah. So yeah, I literally don't need this anymore. And then what do I have here? I have we'll talk about this one. The edge one, this one I haven't done any of this anymore. What is this guy here? Oh yeah, this was those depth maps as well. You don't need this. I haven't done anything here as well, so I don't need to do this anymore because I said the Wan 2.2 14b I got it working. I'm very happy with the result. So I won't need to do this anymore. No, that's not true. For example, next time I have a book cover, if I want to put the book cover on a book, I think I'll still need to do this because one of my favorite online websites where I was able to generate the 3D stuff, that one seems to, I think it went defunct or something, so it looks like I have to figure out how to create 3D covers using ComfyUI or hopefully stable-diffusion in the future. And this is the Z image turbo. So you can see here we're using the same clean image of a mirror cube. Okay. So you see here we're using this the unit loader GGUF, again the turbo 8, because it's a 6B model, 6 billion parameter model. You see I'm using the Q8 here as well. Oh, I'm using the pig one. Okay, so this is the FP32 FP16. And then you see it's 768 by 1024. So one thing that took me a while to realize is that this Z image turbo doesn't have a negative prompt. You have to put your negative prompt everything into the one prompt. That's why you see this is zeroed out. And what else is here? So I created this because some nodes were not working, so I created this latent batch and this latent from batch. So this allows me, for example, if I want to generate an image, image to image, I change this, for example, you see where it says index, I change this to 1 because 0 and 1, so it's going to grab this image. If I just want to make it just a text to image, then I set this to 0, meaning that it will bypass this, and everything stays the same. Now, when if I set this to 1, I need to fool around with this value here so that it takes some of the prompt and some of this image. Otherwise, if I set this to 0, this has to be 1. That's basically all I'm saying. So what I'm trying to say is that this is an image. Right now, this setting is actually wrong. So I will need to put this to 1, then it will take this image and then put it there. Or what I need to do is leave it at 0, then I have to change this to 1, and it will what do you call it? It will use the prompt here. And that's it. And this works as well. So now I'm going to show you some of the results I got earlier, a while back. You guys have seen this before, so I'm not. This is the stable-diffusion. That's not the one we want. So the one we want is ComfyUI. We'll go to the output. So output here. And you can see I was able to generate, these are Z image turbo images, and yeah, so really decent results here. One thing I realized about the Chinese models is that they like to de-age. They're obsessed with de-aging, right? So that was one of those weird things. Like I guess I should put on the, yeah, they like to de-age. like I even tried getting a very old lady, even older than the current mayor of Toronto, and it will always de-age, 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 de-age. The obsession with de-aging is crazy. Alright, so let's go to the video. Where's video? Okay, so these are all the videos, and you guys remember I was obsessed with making this. Yeah, so this was the Wan 2.1. Yeah, so as you can tell, the quality. I was obsessed with the speed, getting it as fast as possible. So I basically abandoned this, because once I got the image turbo working properly, I was very, very, very happy. So got some super weird results. And then when I tried the 5B model, yeah, see this is the 5B model. This is what made me move away from the Wan 2.2 5B model to the 14B. I was not able to get a good result. I wasn't just looking for speed, I was looking for a decent result. I was just not able to get it. I was like, this is even worse than the 2.1 1.3B model. So I'll show you some of, what is this one here as well? Yeah, so as I said, yeah, I was getting some super weird results. Yeah, this is all from the Wan 5B model, because Wan 2.25B model, it's text and image to video, but I was not able to get a decent result. So I was and you see it's obviously trained on humans, and you can see none of the results here were satisfactory. So then what I did was what was this one here? So I went back to my 1.3B to see if that would work, and then I even got this one. Like, how is that climation? That's clearly not climation, right? So I tried even to get it to this is the one 2.25B. I even tried it at its native resolution. Took a long time, but yeah, just got some awkward results. So then I said, hey, why don't I just try 1.3B. I think this is I think it's a 1.3B model. So yeah, I was not getting the results I wanted. Obviously, they're all trained on humans, so I was really frustrated, and I was like, come on! Back to the 5B, I gave it a shot. I really, really, really gave it a shot, but it just would not work. I tried all different types of resolutions. Yeah, as you can see, I was just really frustrated with it. And then surprisingly, then I was going back and forth. So this is the 1.3B model. I was trying to mimic the one from Stable-Diffusion to see if it gets faster. Then I noticed something. I was like, wait a minute, what are all these artifacts? It's like I didn't see them when I did the cat on the command line. So then I was like, oh, that's not good. So I tried to fix that. Yeah, I couldn't get the. You can see the artifacts on the trees here. They look like 3D. They look like they're 3D generated, but they don't look realistic. So I said, okay, let me just run it. So this is the 2.1 1.3B. So you see, obviously this is 1 second, but I'm saying is that it's much better than the Wan 2.2. Sorry, Wan 2.25B. So then I said, hey, you know what? If I go back to the Wan 2.25B, maybe if I give it more steps. I gave it more steps, and the quality never improved. So then I was like, okay, you know what? I gave up. I said, you know what? Let me try what everybody on YouTube says. Go for the 14B, and I did. So this is my first 14B one. It ran for 43 minutes. Yeah, so this was, yeah, this ran for 43 minutes. This one uses both the low and high noise. And then so I ran it again. Then I started looking for speed improvements. I was trying different schedulers, and what's the other one? The samplers as well. Then I noticed something, is that if you notice, this is although it looks like a square, this are not actually squares, they're more of vertical. And then when I did the upscale, I'm like, whoa, that's actually pretty good. So this is all low noise, right? So even just using only low noise without the high noise, you can tell that it came out really, 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 really well. So I was very happy with that. Then I tried it in the what do you call, landscape. Then I realized there's a problem with landscape because I asked for a close-up. So the problem with landscape is that when the character comes to the front, you can't see too much, meaning that obviously I won't be able to use the chickens. You won't be able to see the chickens, so I have to stick to, I guess, vertical, just so they can see, especially for close-ups. Although I do like this one. I think this was a pan. I do like that one. And well, don't I click this one? Okay, so I was just trying different sizes and making it wider so I can fit the character in there. And what was this? Oh, this is the fox one again. Yeah, you can see the problem with the with this image. So I was trying to make it as fast as possible, because I was trying to use the same settings as the stable hyphen diffusion. And as you can see, the quality of the back here is not very good, so that's why I was like, okay, forget it. I tried. I really tried. Tried so many times to improve it using LoRa's, obviously make it fast as well, but yeah, I wasn't able to. And I was like, how come the cat looks okay? Then I was like, am I missing something? It was like it was probably trained on cats. This is using LoRa's. So clearly it was trained on the cat. Anywho, and then what do we do here? You guys have seen some of these. And then you have to be careful with some of those samplers and what do you call it, the schedulers, because this is a human. Like it converted my claymation image into a human. I was like, what? That's not what I wanted. And then of course, this is the one we just did today as well. Very nice. This was 5 seconds as you saw, and I said if I was running all the stuff in the background, it's actually much faster. All right, so I hope that answers the questions about how to generate, how to install and use AI. Oh, I forgot one more thing. The llama. Well, I showed that in the earlier tutorial, so I think you know what time is it? All right, let's run that as well. So let's get out of ComfyUI. I'm gonna stop ComfyUI. Just press Control C here, and then we'll also actually I still need the web browser. So let's go here now. Then just deactivate. Get out of this folder. So there's also llama.cpp, which I forgot to run. So let me run that one, and I'll show you that one as well. We'll actually generate something, because that's what this tutorial is all about. So this we're running that 30B model from the. Did I close it? Okay, here we go. We're running. We're going to run this model. It's not in the ComfyUI, it's in the models. Where's models? This one here. Chat models. This is the model here. You see the size is 21.7 gigs. I could get a bigger one, but I'm okay with this one so far. Oops, wrong one. All right. So I'll show you what command I ran. Llama server. This is also in the Fedora repository. DNF install llama-cpp. You can see it says CUDA stuff, even though it's clearly AMD. It found one ROCm device, and then it loaded all this stuff up. So this ending part here, this is the number of layers, GPU layers, 999. I just made up a number there. Sometimes when you download the image from Hugging Face, it will tell you how many graphical layers it has, and you can put that number here. And then the port, I use 8081 because 8080, as you guys see, I do a lot of tutorials, so I do use that one. And this is the context, 24576. This I made it big enough so this way I can have a conversation with the AI model. If you make it too small, it won't remember things you really typed 1 or 2 prompts ago. And then we have the model here, and that's it. -m for the model. That's all you need. Okay, so it loaded up, and as I showed you, it's not finished yet. I didn't realize. Time for another sip. That's another trick I'll show you guys. Like if you have a very large model, it will obviously take a while to be loaded up, especially if you're using a Llama server. So what I did, that's why I like the smaller model. So you can see here, this one only has 48 or 49 layers for the GPU. So I should really put 49 there. And then you see the size and CPU mapped model. So the CPU part is going to be pretty small, and yeah. So one very important thing is make sure you have a large enough swap file here. Before I used to have a very small one as well, so that also makes a difference, especially if you don't have enough VRAM or RAM. Okay, so this guy is ready. I just need to go to localhost 8081, or the IP address of this workstation, and we'll be ready to go. So I'm using the web UI as well. So I'm just gonna use this one here. This time, do I have an? Oh, I gotta use this one. So this one will go to 8081. Yes, I'm gonna leave. I said 8081. Okay, so here is a llama.cpp. You see it's already got the model, and this is the model here, and it's very sparse. Like all I do is I can set up conversation. I'll show you that in a second. And then the settings, as I said before, if you get the model from Hugging Face, they usually tell you what type of settings are optimized or what it was trained on. This one did not. So I'm just going to use the default settings here that llama.cpp has. But for example, if you wanted to change the penalty samples, you can change all these numbers here in the penalty, meaning that a penalty will prevent it from making mistakes. Reasoning, advanced, and then there's experimental. So this is new. This is still relatively new. So what I do expect is that in the future, that it will come with more. Maybe you'll be able to actually download a model from the web UI and pick the model as well. I guess you give it the path, things like that. So right now it's very sparse, but this actually still was enough that it prevented me from. Remember, I had my own web UI which I created. So I don't use that anymore. I said this one works pretty well. So let's ask it a question. Now you're gonna see why I prefer llama.cpp to Ollama. So I'm just gonna ask. I'm not even gonna bother. You see the temperature is back to idle 43. So if I say, who is the mayor of Toronto? Let's go Toronto, right? Okay. Then it says, as of my last update on June 2024, the mayor of Toronto is John Tory. He had served as mayor since 2014 and was re-elected in the 2022 municipal election. Please check the official City of Toronto website or a reliable news source for the most current information. So this information is even wrong for 2024. Now I'll explain to you why I know this. So the reason I asked this question is because he was mayor during the pandemic, okay? And then he was the one who was so gung-ho for the rest of us to be, stay at home. You can only go outside once a day, whether to go grocery shopping or for your exercise, which is preposterous. And he said, he actually went on news, whatever, or put out a memo, whatever you call it. He was saying that in his condo, they were talking about having remember that nonsense, the 6 feet apart? Not 6 feet apart. Yeah, the 6 feet apart. So he was saying that in the elevator, 2 people should be in an elevator, right? Now, he clearly lives in probably a penthouse suite where he probably has a private elevator. So having 1 person or 2 people in the elevator, who cares? So the problem is, I was living in the corner at the time. So you can imagine, I think mine had 13 floors. So you can imagine, and the stairs were not in use. So the elevator is the one you go up, down, everything. So you can imagine, for that many people, they can't go to work, they can't visit friends and family, they go out to exercise 1 hour or whatever. So there was like a lineup to use the elevator, going up, down, whatever. You know what I mean? So this is the type of idiocy. Well, that's not the point. The point is, while he was coming up with those stupid, ridiculous ideas, he was spending time with his alleged mistress, right? And then when the newspapers found out, he pretended to be honorable and he resigned, right? So that's why I keep on asking this question. And the funny thing is, even in 2026 right now, they still give the wrong answer. It just blows my mind. So basically he resigned. I believe it was in 2022 or 3. I think it was 2022 because it was still during the pandemic. So I believe it's 2022 2022. So he resigned in 2022, just not too long after he had been re-elected, and then basically Toronto didn't have a mayor for about a year. I think it was 9 months. But the reason I say this is because when I asked this question at that time, the correct answer was Toronto doesn't have a mayor. The mayor has resigned or whatever it is. So that's why I'm surprised that it still says this, which is, I said, clearly wrong. So even though the answer is as of my last upload of 2024, so even if this model was updated in 2024, the problem is its information regarding the city of Toronto is clearly pre-2023, right? So most likely it only had up. So this question actually allowed me to find out a lot of information about a lot of models. In that I found out that a lot of these models, they hadn't been updated. I mean, some information hadn't been updated since 2022 or 2023, and this proves it. Now, just because its last update was 2024, that means that maybe all the information was still being gathered. So let's say they finished collecting the information in, say, 2023 or 2022, but I'm saying it's going to take a while for it to be fed to, or this guy to be trained on that information. So that's why. So there you go. So you can run llama.cpp on just a CPU. You don't really need you don't need a GPU for it. Obviously GPU for more intense questioning, but you don't really need it. And as you guys saw, the temperature here is perfectly fine. All right, so that's basically all I wanted to talk about. So let's finish this. Let's finish this up. Let's go to here, and as I said, let's finish this up. So if you want to take your skills further, I also have books. You can see the link to the books on Amazon. The link is also in the description. I also have courses on ojamboshop.com. Then the link is also in the description, and I also offer tutorials. You can contact me on ojambo.com/contact, or for consultation services at ojamboservices.com. Then I also have some other recommended resources. I'm not going to talk about this too anymore because these are going to be removed pretty soon, sometime this week, in the next couple of days. So instead, I'm going to focus on this. Is the Algorithmic Serpent. It's a psychological thriller. It's about a scientist who creates an AI system and loses his mind. And this is the back. This is the paperback version. It's very, very affordable. The majority of the cost goes to printing and shipping for this, the paperback version. And for the ebook version, it's for storage costs. So this is a novelette. You can pick it up right now on Amazon, and let me know what you think. I love writing and not just programming books. My latest, greatest one is the Recession Business Blueprint, and that's a guide to help you start a business during a recession. So if you ever thought of maybe starting a side gig, or maybe you want to get into business yourself, the Recession Business Blueprint will help you, guide you to everything you need to know. Whether you're doing research doesn't just mean about the business. Maybe you want to see what location you should be. Do you need to move? Is it okay to run your business from your home? Doesn't matter. Garage, bedroom, doesn't matter. I ran my business from the solarium in the condo. So basically, my condo was 1.5 rooms, so that's why I run my business. Or maybe you need a budget. You don't know how to budget. You don't know how to. Maybe you need some legal advice. So, Recession Business Blueprint has all the information. Maybe if you need to go back to school, like I went back to school to learn how to learn marketing. So, just do an assessment. All that stuff is the Recession Business Blueprint. And if you have any questions, you can always comment or contact me, and I'll be able to help you out as well. All right, if you want to know more about me, this little blob here, basically I'm a freelance programmer. I'm also an author. You can explore my book on my book shop page on Amazon. And if you need support, ojamboservices.com for consultation services. And if you're ready to learn, ojamboshop.com for the online courses. You're free to use a comment form. It's 14 days after the article goes live. For example, what do we talk about all day today? AI, GGUF, quantization, llama.cpp, stable-diffusion.cpp, ComfyUI, AMD, how to install AMD for ComfyUI, ROCm, system-wide packages, how to install custom nodes without pulling in Nvidia stuff, how to set up using pip. All of that information was today. So you can comment about that, what you liked, what you didn't like. That's perfectly fine. And then the best way to contact me is to use, what's going on here? Why can I go down further? Okay, what is going on here? Wow, okay, looks like this is way too tall. No, that wasn't the intent. Wow, it's still way too tall. Is this cut off for some reason? Okay, there we go. Best way to contact me is ojambo.com/contact or ojamboshop.com rambo.com/contact and jumboservices.com/contact. And if you want to follow me, the channels right now are Odyssey, Rambo, BitChute, and YouTube. And very soon I'm going to add Kick and Twitch. Okay, and one more time, I'd like to implore you to subscribe, like, follow, and leave comments, because the more people subscribe, the more this content gets pushed out to more viewers. Those viewers can join this growing community and post tips and tricks for everyone, or they can post requests which I'll review and then I'll share with everyone. Okay, and now I'm going to put on the outro, and I'd like to remind you that if you want to see what's upcoming, you simply go to jumbo.com, watch menu, lifestyle menu. This is what's upcoming tomorrow at 2 p.m. Eastern. We're going to use AI to create a mega minx puzzle. Then we're going to optimize it the day after. After that, we're going to use this Flux to climb stable-diffusion and the AMD Instinct MI60. Then after that, we have this. I'll show you how you can self-host your own WebGL game server on a Raspberry Pi Zero W. And then after that, I will review this game engine called Little Engine. Okay, so I don't see any chat requests. I hope I didn't miss any, but they should have popped up somewhere around here if there were any. I think there were a few. Let me just quickly double check. Let's see. No, really, no live chats. Okay, that's perfectly fine. So I will then YouTube nothing as well. So I'll see you guys tomorrow at 2 p.m. Eastern. Have a good night, and bye now.